Hello friends, I welcome you in lecture number 18 on group theory. In lecture number 17 we have discussed about cosets of a subgroup in a group. So we first recall that definition. We know that if H is a subgroup of a group G under the binary operation star, then for element A belongs to G, left coset of H is denoted by A times H and is defined as the set of elements of this type A star H, where H belongs to H. And we had seen one example. We have obtained the cosets in this group, addition modulo 4, and the subgroup we had taken was equivalence classes generated by 0 and 2, and we have obtained cosets corresponding to each element in Z4. Today we will discuss some properties of cosets, and for that we will revise, or we will analyze this example which we have done in the last lecture. So we have seen in the last lecture we have obtained the cosets corresponding to each element of Z4. So the coset corresponding to equivalence class 0 was set containing equivalence classes corresponding to 0 and 2. Similarly, coset corresponding to equivalence class generated by 1 was equivalence classes generated by 1 and 3. And coset, left cosets, we have obtained left cosets. Left coset corresponding to this equivalence class was again equivalence classes generated by 0 and 2, and the left coset corresponding to the element this was set containing these two equivalence classes 1 and 3. So now we observe this example which we have done in the last lecture, and from this we try to understand the properties of left cosets. Now first thing is, the number of elements in every left coset are same, and they are 2, and that number is equal to number of elements in a given subgroup. Here there are 2 elements in the subgroup H, and we observe that every left coset of H is having the same number of elements, and that number is equal to number of elements in the given subgroup. So this is not true only for this example, but it is in general true. So if H is any subgroup of a group G, and if A is an element of G, then order of left coset is always equal to order of the subgroup. If we are discussing about finite group, then the number of elements in left cosets are always equal to number of elements in the subgroup. Another observation we can see is that all the cosets corresponding to this are the cosets corresponding to elements of given group Z4 are either equal or disjoint. We can see that cosets corresponding to 0 and 2 are equal. Similarly, cosets corresponding to equivalence classes 1 and 3 are equal, and cosets corresponding to 0 and this 1, if we take their intersection, then there is no element common, that is 5. That means these two cosets are disjoint. Similarly, these two cosets are disjoint. So from this we consider one other property, that if we have any subgroup of a given group G, and suppose we consider 2 elements A1 and A2 in G, then the left cosets corresponding to A1 and A2 are either equal or disjoint. A1H intersection A2H is either empty set or these two cosets are equal. So this is another important property. Two left cosets are either equal or disjoint. Okay, fine. Another observation is if we find left cosets corresponding to these two elements, which are elements of given subgroup. So here we can observe that left coset corresponding to equivalence class 0 is having these two elements. Now this set is nothing but subgroup itself. Similarly, left coset corresponding to element 2 is also H. So this is also another important property, that if we find out left coset corresponding to the element which is also present in given subgroup, then left coset corresponding to this element is always equal to given subgroup. So this is another observation. We will remember all these properties that will help us in writing all the left cosets of given subgroup, and that will save our time also. So whenever we are counting or we are writing the left cosets corresponding to the elements of a given subgroup, then that left coset is always equal to given subgroup, like this. Here 0 is an element of H, therefore left coset corresponding to equivalence class 0 is subgroup itself. Similarly, left coset corresponding to this equivalence class 2 is also subgroup itself. And another observation is, here we can see left coset corresponding to 1 is having two elements 1 and 3, and here this 3 element belongs to this equivalence class. Equivalence class generated by 3 belongs to left coset generated by equivalence class 1, and we can observe that these two are equal. Left coset corresponding to this element is equal to left coset corresponding to this element. So this is also general property, that we have this type of situation. Here also we can observe this is the equivalence, this is the left coset generated by equivalence class 2, and this 0 is an element of this left coset, and we can see that equivalence class is generated by 0 and 2 are same. Left cosets generated by 0 and 2 are same because this is in this set. So in general we have this type of property, that suppose element A1 is a member of left coset generated by A2, then A1H and A2H are always equal for any A1, A2 which are members of given group. So these two properties are very important. They will reduce our time in writing the left cosets. And the last observation is, if we take union of all these left cosets, if we take union of all these sets which are left cosets, then we will obtain group Z4. We can write Z4 as union of 0H and 1H left cosets generated by 0 and 1, or we can write 1H union 2H. This means, and these two are disjoint and these two are also disjoint. That means left cosets form a partition of Z4. If we take this set having these two left cosets 0H and 1H, then these two elements are disjoint and their union is Z4. Therefore, this set is a partition of Z4. Similarly, if we consider this set 1H and 2H, then this is another partition of Z4. If we take union of these two, we obtain Z4, and these two are disjoint. So this is always true that the left cosets of a group G construct a partition of G. Suppose G is a group and H is a subgroup of G, then we can always write G as the union of union of left cosets. Here we write A belongs to G. So the left cosets of a subgroup G form a partition of group G. So we will remember all these properties. So now we summarize all these properties which we have just discussed. Let capital H be a subgroup of a group G. Then any two left cosets of H are either equal or disjoint. This we can write mathematically as, if we take any two elements of a group G, say A1, A2, then A1H equal to A2H or A1H intersection A2H is empty set. This means any two left cosets are either equal or disjoint. Another property we have discussed is, if A is an element of subgroup H, then left coset corresponding to A is always equal to subgroup H. A belongs to H implies AH equal to H. So what is benefit of this? When finding all the left cosets of H, we need not compute AH for A belongs to H, because this is going to be equal to H. Another property is, if A1 is an element of A2H, then left coset corresponding to A1 and A2 are always equal. And the last one was about partition. The set of left cosets of H in G form a partition of G. Every element of G belongs to one and only one left coset of H in G. And we have seen this example last time. The left cosets of H are 0, 2 in Z4 are these two sets. These two sets are left cosets of this subgroup H, and Z4 can be written as union of these two left cosets, and both are disjoint. So this set, which contains two sets which are left cosets, form a partition of Z4 with respect to addition modulo 4. So we can now, using all these properties, we again do the same example which we have done in lecture number 17. So we again do that problem. Determine all left cosets. Determine all left cosets of H equal to equivalence classes generated by 0, 2 in a group Z4 with addition modulo 4. But we will use now properties which we have discussed to minimize our calculation as well as time. So first property we will use is, we know that if an element is a member of subgroup, then left coset generated by that element is subgroup itself. And before that we just write down Z4 is having 4 elements, equivalence classes generated by 0, 1, 2 and 3. Now equivalence classes corresponding to these two elements will be equal to this subgroup itself, because these two are elements of given subgroup. Since equivalence class generated by 0 and 2 are elements of H, we can directly write that left coset generated by this element 0 equal to left coset corresponding to equivalence class 2 will be equal to h, and it is nothing but 0 2. So for these two we have done for 0 and 2. Now we find out left coset corresponding to 1. So for that we use the definition of left coset. 1h, here operation is addition modulo 4, so this we can write in this way also. By definition of left coset, this is equivalence class generated by 1 addition modulo 4, where this equivalence class generated by h is an element of subgroup. So first we write these elements. So there are two members 0 and 2. So first I write equivalence class generated by 0, comma, then I will write equivalence class generated by 2. Now using that operation addition modulo 4, 1 plus, this is going to be 1 plus 0 modulo 4. That is, we have to write down remainder when 1 is divided by 4, or we can write one more step, 1 plus 0 modulo 4, and here 1 plus 2 modulo 4. 1 plus 0 modulo 4 means 1 modulo 4, that is remainder when 1 is divided by 4, and because 1 is less than 4, this is equal to 1, remainder will be 1. Similarly, this is 3 modulo 4 and 3 is less than 4, therefore we obtain this one. So this is the left coset corresponding to the equivalence class 1. Left coset corresponding to equivalence class 1 is having two elements, and the last one we have to obtain is equivalence left coset corresponding to the equivalence class 3, but that we will not calculate using this definition. We will use that property. We know that if A1 is an element of A2H, then equivalence class, then left coset corresponding to A1 and A2 are equal. So now you can observe that this element 3 is a member of this left coset. So using this property, we can write that left coset corresponding to 3 will be equal to left coset corresponding to h corresponding to 1, and this we have obtained. It is having two elements, equivalence classes generated by 1 and 3. So if we are familiar with the properties of left cosets, then this will save our time. Here I have obtained this only by definition, and other left cosets I have written using the properties of left cosets which we have just discussed. So I hope you have understood how to find out left cosets of a subgroup using the properties of left cosets. So I stop here. Thanks for watching.